Hello students, today we are going to discuss about Claisen condensation reaction in the topic of reaction today. Claisen condensation is a type of a reaction where new carbon-carbon bond forms, and this reaction takes place between two esters or one ester and another carbonyl compound in presence of a strong base like sodium methoxide or sodium ethoxide. So now let's understand how a new carbon-carbon bond is forming in the Claisen condensation reactions. So in this reaction, we have taken ethyl acetate, and in presence of a base like sodium methoxide, a carbon ion is forming. Now this carbon is a nucleophilic center. Now another molecule of ethyl acetate, this is an electrophilic carbon. So now this carbon is electrophilic center and the carbon and carbon is a nucleophilic center. So now the nucleophile attacks to the electrophilic carbon, and that's way you can see there is a new bond is forming between the electrophilic center and the nucleophilic center of the two carbon, and this is a new carbon-carbon bond is forming due to Claisen condensation reaction. Claisen condensation reaction, the alpha hydrogen should be present. So here you can see there are the three examples of ester we have taken, and this is the alpha carbon. In alpha carbon, this alpha carbon doesn't have any alpha hydrogen. So that means it cannot undergo Enol formation. Now in the second structure, here you can see this is the alpha carbon and it has a alpha hydrogen. So that means it can undergo in Enol formation. In the third molecule, so this is the alpha carbon, but alpha carbon doesn't have any alpha hydrogen. That means it cannot form a Enol. So if the ester molecule doesn't have alpha hydrogen, it cannot form a Enol. So then in the self-Claisen condensation reaction, that particular ester which doesn't have the alpha hydrogen cannot undergo Claisen condensation reaction. So that means out of these three examples, only the middle one which has the alpha hydrogen is only the right candidate for the Claisen condensation reaction. Now let's understand the reaction mechanism of Claisen condensation reaction. So this is the ester we have taken. It's a ethyl acetate. This is alpha carbon. Alpha carbon has alpha hydrogens. Alpha hydrogens are acidic in nature because it is adjacent to the electron withdrawing carbonyl group. And this alpha hydrogen can participate in Enol formation. Now what happened? Here we are using a base, sodium methoxide or sodium ethoxide. Now this hydrogen is acidic in nature, so deprotonation will take place in presence of a base and a carbon ion will form. Now this carbon ion can undergo resonance in this way. The electrons will move towards the carbon and then the double bond will break towards the O-. So this is the enolate. And now again the negative charge will move towards the carbon and then the double bond will break and then the negative charge will come back to the carbon. So now here you can see this is the carbon ion is forming in this reaction and this is in between, it's a enolate. So formation of ester enolate is very important, and that's the reason presence of alpha hydrogen is important for Claisen condensation reaction. Now one nucleophilic center is present. Now another ester molecules are present in the reaction mixture where this carbon is electrophilic in nature. Now here you can see this nucleophilic center is attacking to the electrophilic carbon. So now a new bond is forming between the nucleophilic center and the electrophilic carbon. So this is the new bond. Now in the final step, you can see that negative charge over the oxygen is moving towards the carbon, and thus a double bond forms, and OC2H5 is leaving as a leaving group. And this is the way we are getting the final product. So the yellow color one, you can see this part is coming from the one molecule of ester where this carbon is electrophilic in center, and the blue part, that is also coming from another molecule of the ester, but this carbon is acting as a nucleophile. And then there is a new bond between an electrophilic carbon and the nucleophilic carbon. And here you can see that this is the ester group. So this carbon will be alpha carbon, and at beta position the carbonyl group present. That's why it is called beta keto ester. So now you understand that in Claisen condensation reaction, ester in presence of a strong base form beta keto ester. In Claisen condensation reaction, the product is either beta keto ester or beta diketone. Now in this product, here you can see this is called the methylene carbon, and each methylene carbon having the methylene proton. So these methylene carbons are present in between the two carbonyl groups, and carbonyl groups are electron withdrawing, which makes this methylene proton acidic enough to get deprotonated by the base which is present in the reaction mixture. So now here you can see these are the two types of beta keto ester, and they have the methylene proton. So as we already explained that methylene protons are acidic in nature. So in presence of base, this deprotonation takes place. So that means one carbon ion form here. Similarly, it's going to happen with the another molecule. So that means in the Claisen condensation reaction, the product beta diketo ester is further undergoing a deprotonation reaction in presence of a base. So that means it is very much necessary to work up the reaction mixture with the acid. That means acidic workup is very much important in Claisen condensation reaction so that this deprotonation can be prevented. And then finally we will be getting the desired beta keto ester. This is an example of cross Claisen condensation reaction between two different esters. So here we have taken two different esters, ethyl acetate and methyl benzoate. Now ethyl acetate having an alpha hydrogen which is enolizable, but in methyl benzoate this alpha carbon doesn't have any alpha hydrogen, so it is not enolizable. That means in presence of a base, the ethyl acetate will form the carbon ion. That means ester enolate will be forming, and this is acting as a nucleophile. Now the methyl benzoate, the carbonyl carbon will act as electrophilic center. So now the nucleophilic center will attack to the carbonyl carbon which is electrophilic center, and a new bond will form between the electrophilic center and a nucleophilic center, and then finally we will be getting beta keto ester. So this is the product of crossed Claisen condensation reaction. Now this is another example of cross Claisen condensation reaction, that is between ester and the ketone. So in this example here you can see that in the ethyl benzoate the alpha carbon doesn't have the alpha hydrogen, but the ketone having the alpha hydrogen. So that means in presence of a base the carbon ion will form in acetophenone molecule. So this is the carbon ion is forming. Now this carbon ion will attack to the electrophilic carbon of the ethyl benzoate. Then finally a new bond will form between the electrophilic center and the nucleophilic center. And then finally we'll be getting a product that is the beta diketone. Now this is another kind of example of Claisen condensation reaction, which is intramolecular Claisen condensation, which is known as a Dieckmann condensation reaction. So here in this molecule you can see the one end, both the end having the 2 ester group. Now in presence of a base, the alpha hydrogen will be deprotonated. Then a carbon ion will form. So that means here you can see the carbon ion is forming on the C6 carbon. Now C1 carbon having a carbonyl group. So this C1 carbon is electrophilic in nature. So now C6 will attack to the C1 carbon and a new bond will form between the C1 and C6. Then finally we'll be getting this product. So this is the final compound of the Dieckmann condensation reaction. I hope you understood the Claisen condensation reaction, what kind of starting material, the reactant we should take for this reaction, and what is the reaction mechanism, and how we are getting the product like beta diketone or beta diketo ester. If you have any doubts, you can send me a mail to chemistry.affinity@gmail.com. Thank you for watching this video.